All right, so we're going to look at number 17 and 18 in the problem set. So a couple students recommended that I work this one out and give some solution paths to it. So let's go ahead and get started here. So we have the scenario. This is a lottery situation where you're buying cards and you have payouts. This is the Florida Scratch Card Lottery. The numbers and values of prizes awarded for every 100,000 cards sold are, and they have this little box here to show that. Now, one of the key things to notice about this problem is there are 100,000 cards, but how many do we see? We see 6,010 in here, right? That's what we see. All right. So the number of cards, here's the payout. And so we're interested in this for number 17, the probability that a random scratch card will pay off. Okay. So we're interested in this. This is our random variable. Okay. And then we don't even have probabilities. We don't have a column. So if I were to draw this, we don't have a column that shows probabilities. Let me adjust my bar here. So if I were to extend this, I would want a section for probability of payoff, right? Okay, there we go. That's what we're going to put in here. So what is the probability that we're going to get paid for this first one? We want to know. Well, there's 10 cards, so 10 out of 100,000, right? That's what should go in here. Now, what is that as a decimal? I'm also going to have that, so 10 out of 100,000. That's 0001. 3 zeros and 1. There we go. Okay, then we're going to do the same thing for this one here. This one's going to be a little bit better odds. 1,000 out of 100,000. What's the decimal equivalent of that? 0.01. So that's a lot better. That's 1% chance. Still not great, but definitely better. And then finally, probability of a $5 payout. So we have 5,000 out of 100,000. And I believe without checking, that's going to be 0.05. Okay, I will check, fine. 5,000 out of 1,000. Okay, good. So there's that. So we filled that in. So the total probability of payout is going to be all of these added together. Okay, so let's do that. So plus 0.01 plus 0.0001. So there's our probability that it's actually we're going to get some money, right? So the best choice on this one is going to be, and make sure that you notice that I was about to say D, but D is not correct because the decimal place is in the wrong spot. There's a 0 there, so it's actually B. Okay. All right. So next it says find the expected payoff per card. Remember, this is a random variable, so this is mu of x, and this isn't a binomial random variable or a geometric random variable. This is just a random variable. It's not binary because there's multiple things that could happen. And we're not just breaking it down to win and loss. We have $1,000, $50, $5, and then there's actually another event that could happen here, which is you get no dollars, right? We haven't written that out yet, but that's actually pretty important for this distribution. Is that you could get, and you'll add this to your chart here. You could get paid out nothing. And how many cards are going to pay you nothing? Well, it's 100,000 of those but we got to take away the ones that win, which is 6,010. This is the amount of cards right here that don't pay out. So we're going to put that in here. And now we want to make the probability, which is out of 100,000. So let's see what that is. So divided by 100,000. So yeah, 0.9399. All All right, so now we have a completed, like this is the total distribution, and all of this is going to add up to 100% here if we were to add it. And we can actually find this expected payout. So we've seen how to do this from our lessons over random variable. Back in our notes, this was the actual formula we would use, like if we were going to do it by hand, but we don't really do it by hand for this. We actually are going to use our calculator to create or to do this. So let's get our calculators out. So I've got mine on my other display over here. So we need to create a new listing spreadsheet. Okay, we'll just call this payoff here, just to keep it in context of what we're working on, and then we'll say P payoff. Or if you like X and P of X, you can do it that way too. But we know that our payoffs are 1,000, 50, 5, and 0. Okay, it doesn't tell us how much these actually cost, so we're not gonna say we're making negative on it. We're just gonna put 0, right, for the expected payoff per card. This isn't like net profit like some of the examples that we've done, okay, when we're talking about a lottery, like the Keno example. So let's go ahead and type in our probabilities. We have 0.0001 is the first one. Then we have 0.01, 0.05, and then the last one, the probability of getting nothing, is 9399. And then once we have that in there, again, slow me down and rewind if you need. Get this again, that's fine. We're gonna press menu 411. Remember, on this, we want payoff, or our X variable, or the actual random variable itself, to go first. And we have to change our frequency list to the probabilities. So we hit enter, and this is the value that we want. Okay, so I'm gonna go back over to my main display here, and for our mean expected outcome, you're expected to get paid 85 cents. Now, we don't know how much it costs to play this game. Like if it costs you $1 to play, you're really gonna lose money. You're gonna lose 15 cents each time you play. But for this, the expected payout, you're supposed to win 85 cents per time that you play. That is what should happen, okay? All right, hopefully that was helpful. And if you have any follow-up questions, feel free to ask. If you want me to work any more, I can try to get those done.